So in this question we've got a particle Q moving in a straight line across a rough surface. So I've started the diagram here. So Q is moving along in this direction and this surface is a little bit rough. So we've got a coefficient of friction to calculate here. Now it's been given as coefficient of friction is 0.4. So going in this direction we've got friction is 0.4. Now the driving force of this particle Q is d newtons. So d is going in this direction. Acceleration is 0.91 meters per second squared. So that's going to be 0.91. So that's our acceleration. Now Q has a weight of 0.65 newtons. So therefore force acting down there, 0.65 newtons. So this one here is the normal force, and we're going to have a force going in this direction, which I'm going to call just force 1. Okay, what we want to do is find out what this force D is. So we've got the acceleration, we've got the weight of the particle, and we've got the friction here. So that's what we need to work with. So where are we going to start? Well, we've got here the coefficient of friction, and we've also got the particle has a weight of 0.65 newtons. So that's the force there acting on it. So therefore we can resolve the forces. So resolving in this direction, we get force 1 equals is the coefficient of friction multiplied by the resolving force in that direction. So what have we got? 0.4 is the coefficient of friction, and the force acting on the box or particle is 0.65. Okay, so what is force 1? Well, 0.4 times 0.65, put that in our calculator, we get 0.26. So force 1 equals 0.26. Now, what we should get now using Newton's second law, using force equals mass times acceleration, we should get force D minus force 1 equals mass times acceleration. Now in this case acceleration is 0.91, so we can write mass times 0.91. Now force 1 we know is 0.26, so we can do D minus 0.26. Now what is the mass? Well, we're given here is the weight, not the mass. So the weight is 0.65. So that's a key piece of information there that could trip us up. We need to find the mass. Now what we do know is that this particle has a force acting on it of 0.65. Now if we take the gravitational constant, so let G equal 9.8, that's the gravitational constant due to acceleration of a body force acting on it downwards. So we know force equals mass times acceleration. Now we know the force, we don't know the mass, but we know the acceleration because it's the gravitational constant. So if we can change that to force equals mass times the gravitational constant, and then the mass we can isolate by dividing G both sides. So then mass equals the force divided by gravity, the gravitational constant. So force acting on it is 0.65, gravitational constant 9.8. So if we put that in our calculator, we'll get something that's approximately 0.0663. So that's what our approximation for our mass is. So now we can come back into this one, and now we know what mass is. So now solving for D, we can have D equals, add 0.26 to both sides, plus this value here for mass, which is 0.0663 times 0.91. So 0.26 plus this multiplied together, D is going to be 0.3204 to 4 decimal places. And the force of that is going to be in newtons. So that is going to give us our answer for the force D. Okay.